Hello everyone, I am Shankar, Assistant Professor, Department of Information Technology, Dr.M.G.R Education Research Institute, Chennai. Welcome to the video lecture on the topic log-based recovery in database management system. Why recovery is needed in database management system? So, whenever a transaction is submitted to database management system for execution, the operating system is responsible for making sure to confirm all the operation is performed in a transaction have successfully completed and their effect is recorded in a database or not. Why we need database recovery? In database recovery is needed in case of various types of failures occurs in a database. So the failures are transaction failure, system failure, media failure. So transaction failure means transaction may fail because of given any incorrect input. Sometimes deadlock also occurs. So system failure is nothing but if operating system is fault, otherwise the RAM get fail, that is gets damaged. Media failure means if any disk head crash, otherwise and power problems occurs. So this type of failure is related to media failure. So next, what is database recovery? So the database recovery is a process of restoring the database to the most recent consistent state that existed just before the failure. So whatever the database we created, the database in any of the three states, we can recover our data. The states are precondition state, condition state and post condition state. Based on these three states, we can recover our data. So the main thing is to recover the data based on log file. So that is a log based recovery. So in log based recovery, so how we can recover within a log, how to write a log operations, how can we perform undo or redo operations on a log to recover from a log failure. So these three things comes in detail of log based recovery, discuss one by one. So before that, so what is the definition of a log? Your log means it is a small file, that is a sequence of records recording all the update activities in the databases. So it is the most widely used structure of recording the database modifications. If any operations which is performed on the database, that is recorded on log. So it is a sequence of records which maintain the record of actions performed by a transaction. We have to perform all the transactions that we are performing on the memory area that belongs to transactions. So first we make a log, in that create a record of all the transactions and its operation is going to be update. So now the log records we can perform inside the database, which can be transferred to disk buffer. So the disk buffer can store the modification data, otherwise it can store the result also. So therefore first the log need to be modified and then we can update the value. So whenever there is instructions in the log, first we need to modify the instructions in a disk buffer, then we can perform the instruction operation modified on a disk. This is known as log records. We can make a log record in the form of having a 4 fields: transaction identifier, data item identifier, old value, new value, that is a ti comma xi comma vi comma vj. So transaction identifier is a unique identifier for the transactions which is going to perform a write operation. A data item identifier, that is xi, it is a unique identifier of a data item return. So this xi, that is a data item identifier, is otherwise known as location of x. The next one is a vi, old value. So it is a value of data item prior to write operation, that is before the transaction write operation. So vj, that is a new value. It is a modified value of a data item that will have perform after the write operation, that is after the transaction of write operation. So some more transaction comments found in a log records. So in log file is kept on a stable storage media. So the transaction commands are tn comma start, next one tn commit, tn abort. So tn comma start, when a transaction enters the system and start execution process, it writes a log in the form of tn comma start. So next, when the transaction modify an item x, it write log as in the form of tn comma x comma v1 comma v2. So it means it reads the transaction has changed the value of data item x from the old value to new value. Old value is a v1, new value is a v2. So when the transaction finishes, that is a tn commit. So when we perform the commit operation, the transaction has successfully completed all the updates in a disk buffer. When the transaction aborts, that is tn aborts. So we can find the tn aborts means the transaction cannot proceed further. So when we use a database recovery, so whenever we lose the database, if any system failure occurs or any interrupt occurs, so we want to recover the database. To recover our database, we follow some techniques. So what are the techniques? So the database can be modified, otherwise there are two basic database update techniques to recover our data. One is a deferred database modification, another one is a immediate database modification. So what is deferred database modification? That is a deferred update. So deferred means that is a delay, that is a write operation delay. So the transaction operations do not immediately update the physical database. The database is physically updated only after the transaction reaches its commit stage. So this is a deferred database modification. That is, all logs are written onto stable storage and database is updated when a transaction reaches the commit operation. Immediate database modification. The database is immediately updated to the transaction during the execution even before it reaches the commit operation. In immediate database modification, each logs follows an actual database modification. So that is, the database is modified immediately after every operation. So what is deferred database modification? So in deferred database modification, scheme records all the modifications to the log but defers all the writes to after a partial commits. So the transaction, already we said the transaction start by the log operation is ti comma start, it is a record to the log. Next, so in deferred database modification, the log record in the form of ti comma x comma v. Here v is a new value. So when a ti partially commits, that is a ti commits is written to the log. Example, if a transaction, consider two transactions t0 and t1. So the t0 execute before t1. So after completing the t0, next the t1 execute transaction execute the process. So in a t0, initially the database contain a values for account A as 1000, account B has 2000. So the transaction in database value of account A is 1000 and B is 2000. So then the transaction. So in a transaction, first read of A equal to A minus 50, write of A, read of B equal to B plus 50, write of B. So initially A having a value is 1000. So now perform the operation. Modification is a equal to a minus 50 means now the a value is 950. Then write of a, the 950 is stored in temporary storage. Then read of b equal to b plus 50. Write of b, so b having a value is 2000, so 2000 plus 50, 2050. So the write of b having a value is 2050. In a read of c having a value is 700, so c equal to c minus 100. Now the c value is 600. So during recovery, after any system failure, that is any crash, a transactions need to be redone if and only if both transaction TA start and TA commits. So in the table, in the figure of the table, the A table, so there are three logs: T0 comma start, T0 A comma 950, T0 B comma 2050. Because in a default database modification, the log formation is transaction identifier, data item identifier, and the new value. So the new value of your write of A operation is 950. The new value of your write of B operation is 2050. Here there is no commit operation performs here, so there is no redo actions need to be taken to restore the original value. So in B, T0 start, T0 A comma 950, T0 B comma 2050, T0 comma commit. So here already we said a transaction need to be redone if and only if both TA start and TA commit operations perform. Here T0 start and T0 commit operation has both operations has to perform, so we can redo the value. So we can redone the value means the 950 and the 2050 is updated in a databases. TA comma start, TA comma C comma 600, only TA comma start is there. So T1 comma 6C comma 600. So the write of C is 600 because the in database the C value is not updated to 600 because there is no commit operation performed here. The third C in a T0 comma start, T0 comma A comma 950, T0 comma B comma 2050, T0 comma commit. So here read an operation perform because T0 start and T0 commit both operations are to perform. T1 comma start transaction, T1 comma start, T1 comma C comma 600, T1 comma commit also. So here both the transaction T0 and T1 has to read on the operation, has to be updated the new value in a databases. So when the database has to change the value after it reaches the commit operation. So in a first A there is no commit operation, so there is no redo actions need to be taken. In a B, redo of T0 must be performed since T0 commit is present. When the T0 commit is present, so read operation has to be performed to change the value updated in a databases. So in C, so redo of T0 must be performed followed by redo of T1 since both T0 comma commit and T1 commits are present. So this is a deferred database modification. So in deferred database modification there is no undone and redo operations performed directly. So the redo operation is performed when the transaction reaches the commit operation, then only we have to update the value in a database. Otherwise in database there is the value won't be changed. So in immediate database modification, the immediate database modification techniques allows the database modifications to the output to the database while the transaction is still in a active state. So updated log record must be written before the data item is written. So the output of updated blocks can be take place at any time before or after the transaction commit. So in immediate database modification, the recovery procedure has to perform two operations instead of one operation. So in a default database modification, read an operation when the transaction reaches the commit, it perform a read an operation. In a immediate database modification, two operations has to perform instead of read. So the operation is one is a undo operation, another one is a redo operation. In undo operation, there is an undone transaction. It restores the value of all data item updated by a TJ to their old value going backward from the last log record for transaction Ti. In read operation sets the value of all data item updated by a transaction Ti to the new value going forward from the first log record for transaction Ta. So when recovering after any system failure, the transaction Ta needs to be undone if log contains the record. So Ta comma start but doesn't contain the record Ta comma commit. The transaction Ta needs to be redone if the log contains both the record Ta comma start and Ta comma commit. So that is, if undone, only the Ta start is enough. In redone, both the Ta start and Ta commit operations contains both the log record operations. So undo operations are performed first, then a redo operation. So coming to the example, so the same example. So already in our database we having two accounts. One is A, value is 1000. Another account B, value is 2000. So the transaction, first read of A equal to A minus 50, A minus 50, write of A, read of B, B equal to B plus 50, write of B. In a read of A contains the value is a 950. In a write of B, the value is a 2050. So in a log, so in immediate database modification, the log records in the form of 4 fields: transaction, identifier, data item either A or B, old value, new value. So here in first A, T0 is a transaction identifier, A is a data item identifier, 1000 is for old value, the new value of A having 950. In a B, 2000 is a old value, 2050 is a new value. So here in recovery, to recover our data after the T0 start log record performs. So in first A, undo of T0. So B is restored to 2000 and A to 1000. So if any system failure after updating this value, so we can perform the undo operation, that is we can restore to the old value. So B having the new value is a 2050, we can restore to the old value is a 2000 and restore the new value of 950 to the old value is a 1000. The undo operation perform. So in immediate database transaction, if Ta start, it doesn't commit, it does not perform any commit operation, we have to undo the operations. So in second one, T0 comma start in B, T0 comma A comma 1000 950, D0 comma B comma 2000 comma 2050, T0 comma commit. So if a commit operation, if a T0, if the log contains both start and commit operation, we need to redo the transaction. We have to update the new value in a databases. So the new value of database is 950 and 2050 instead of your old value, because when we reach the commit operation. So T1 comma start, T1 comma C comma 700 comma 600. Here there is no commit operation perform, only start operation is there, and update the value in a write of C. The new value is a 600. So we can undo the value to the previous value 700, but we can't redo the new value in a database because there is no commit operation performed here. In C, T0 comma start A comma 1000 comma 950, B comma 2000 comma 2050, T0 comma commit, T1 comma start, T1 comma C comma 700 comma 600, T1 comma commit. So if both the transaction has the log records of T0 comma start, update the records and the commit operation. T1 has start, update and the commit operation. So we can redo the operation of both the transaction T0 and T1 because it reaches the commit operation. So A and B values are 950 and 250, 2050. Now the C value is also a 600. So this is a immediate update databases. So the next one is a recovery with concurrent transaction. When more than one transactions are being executed in a parallel, the logs are interleaved. So here all transactions share a single disk buffer and in a single log field. A buffer block can have a data item updated by one or more transaction. When a system failure occurs, we must consult the log to determine the transaction that is need to be redone and that is need to be either a undone operation. So rather than reprocessing the entire log, which is time consuming and much of it is unnecessary, we can use a checkpoints. So where we use checkpoints, it is a type of mechanism where all the previous logs are removed from the system and permanently stored in a storage disk. So it is look like a bookmarks while the execution of transaction. Such a checkpoints are marked. The process when it reaches to the checkpoint, the transaction will be updated in a databases. Until that point, entire log file will be removed from the file. So the checkpoint is in the form of checkpoint comma L, where L is the list of transaction active at the time of a checkpoint. When the system recovers from a crash, it first do the following: initialize both undo list and redo list to be empty, scan the log record backwards from the end, stopping when the first checkpoint record is found. So for each record found during the backward scan, if the record TA commits, add the transaction to redo list. If the record is a transaction start, if TA is not in a redo list, add transaction TA to the undo list. For every transaction TA in a list of transaction L, if TA is not in a redo list, add the transaction TA to undo list. So this is a diagram. If any system failure in the transaction, we must scan the backward to the log found in a checkpoint so we can recover our data in easiest manner. So that is, a checkpoint is used to declare a point before which the database management system was in a consistent state and all the transactions were committed. So this is recovery with concurrent transactions in a log based method. So thank you.